Welcome to the Arcfluence podcast, where we talk about how design impacts the way we live, work, and invest. I'm Nick Karakan, your host, and with me today, as always, are my business partners and co-hosts, Paul Fatkins and Nino Samojic.
Good morning.
Good morning.
Yeah. How you guys doing today?
A little cold, a little tired.
Yeah, you were just in the Swiss Alps.
Yeah. Swiss and French.
French Alps,
Yes.
yeah.
Don't forget the French.
Yeah. So it was great. It was a good trip. So just still adjusting to the time zone difference coming back.
Yeah.
So how long did you stay?
We were there for a week.
For a week.
Yeah. And
Nice.
we pretty much jumped around to a couple of different ski resorts.
Mhm.
We were in Courchevel, Les Contamines, and there's one other I can't think of. The name is slipping my
Mhm.
mind. But yeah, we were basically just skiing the whole time. So
Yeah, you brought your son. You did a whole family excursion.
Yeah.
Nice.
Yeah. So
Nice.
and all he wanted to do was go on. He's like day one, first time on the snow and up in elevation and completely have no idea where I am in the world
Mhm.
on the mountain, like where the trails are, where the lifts are, nothing.
Bye, Dad.
Yeah, kind of. And it's like, well, let's go over here to this Black Diamond over there, like the most difficult, challenging. Yeah,
Yeah.
let's go there. It's like, no, let's warm up first.
Yes.
Just calm down.
To be young again.
Yeah.
I know.
So he was
Time's
excited.
fly.
Fearless.
That's good.
Yeah, he
That's
loved
good.
it. He loved it.
That's
So,
good. That's good.
Glad you had a good time.
Yeah.
Yep.
But anyway, back to reality, right?
Yep.
So, yeah.
No, we're having fun back at work. I missed you. I'll be honest.
Did you? I'm not surprised.
We're gonna have to plan ahead next time you want to go on vacation.
Yeah.
I might go with you.
Yeah.
Actually,
I think
just
that's-
close the firm.
Yeah. That is the next one, right? We're going to be in Italy together.
There you go.
So,
yeah.
That's coming. It's soon. It's coming up.
Just put like a Danny in hot spot. Like Danny, you're in charge now.
Yeah. Good luck.
Sounds
Yeah.
like a plan.
Yeah, but this one in Italy is gonna be a little bit longer. Was it? Yeah, it's
10 days.
I think we're there
11
for
days.
10, 11 days. Yeah.
yeah. I'm gonna be 3 weeks
Yeah.
in Europe.
Yeah, we're meeting up with you.
Yep, it's gonna be fun.
Yeah. I just can't wait to our test drives. That's going to be.
I know.
It's going to be the highlight of the trip.
Same.
Nick and I talked about that when we were in Paris the last time.
Yeah.
We were walking across the city because the subway had closed, and there's no other.
There were strikes
no,
again.
At 2 a.m.
No,
at-
they just close.
yeah. Oh yeah, they close at midnight.
Midnight.
And there was
Yeah.
no taxis. There's
Nope.
nobody on the street.
Nope.
Everyone's asleep.
Nope.
By the way, that's one of the things I noticed when I went back to Europe this time
Yeah.
too. Everything's closed like at 5, 6
Oh, yeah,
o'clock.
of course.
On Sunday, they don't even open the grocery stores.
Yeah.
Oh my god.
So yeah, it was fun to navigate.
You seem really upset by this.
I am. I was like, I'm Eurocentric. I want Europe to
Yeah.
survive, not to turn it a museum.
But when we were walking across Paris, Nick was like, "Just give me. I'll take a smart car, even like something to get
Yeah.
me from
A
here to our
bicycle.
hotel."
Yeah.
Instead, we're walking 8 kilometers to the hotel across Paris at 2 o'clock in the morning after we got out of the club.
I
Yeah.
did the same. I was actually walking from the Opera Garnier all the way to the Pigalle
Yeah.
for 3 hours.
Yeah. Oh, yeah. It was. I think we got home just before 5 a.m.
Yeah.
Around
Yeah.
5 a.m.
It was
Like the
insane.
subway was opening by the time we got home.
Yeah.
Yeah.
So it's just like, come on.
Insane. Okay, let's go back to the
Yeah,
topics. What are we
sorry.
talking about today?
Today we are talking about architecture, terminology.
Terminology.
You're the
yeah.
one. You're the one on the hot seat now.
Yeah.
So I'm actually got a list of common terms that we use when we're talking to clients, when we're talking about projects, and we're just going to go through some of these terms and talk a little bit about them so that we can have better awareness about these projects. These are things that are good to know when you're speaking with your design professional, and they're probably going to come up in conversation, sometimes mostly in the commercial space, sometimes in both residential and commercial.
Yep.
So we're going to start with an easy one. I'm going to be asking you guys the definition of these, and we can talk.
Is this? Are we trying to like think of what the definition is exactly, or what it means to us? I think it'd be like a little bit of both, right?
A little bit of both.
Yeah.
Yeah.
It can be whatever you want.
And
Paul.
how I exactly.
Well, everyone has a different. It can be subjective. Architecture is technically a little bit subjective.
It
right?
is.
Everything except
Yeah.
for code is subjective.
Exactly.
Even
Even
code
can be.
Even
Code has gray areas.
Yeah.
There's interpretation
Yes.
within the code.
Exactly.
Right?
Yeah.
100%.
Our
Yeah.
friends at the plant examiner's office.
Oh yeah.
Shout out.
Shout out.
All right, let's start with programming.
Yeah.
Okay.
So so programming is pretty much like sometimes like a program is actually defined by the client, sometimes it's defined by the architects, but it's pretty much like understanding what kind of functionality is going to be in a space and how these functionality are connected to each other. That's
we'll see this a lot on new builds in the commercial space where if we're doing a development project.
To me, it's like what do you want to use the space for?
Exactly.
Basically. And if somebody comes up and says, well, I'm taking over this space and I'm going to divide out a little chunk of it for this like mini shop. Okay, well, what's the mini shop? Like, is it an office? Are you selling things out of it? Like, what is this mini shop concept?
And you have programming within programming. So like this might be a loading area and this is going to be storage and this is going to be the retail space. And this is going to be the entry. So like,
yeah, we go like from the broad pictures, like what are you going to use space for it, and then we're going to use that space and divide into subspaces and sub-functions, and then we're going to determine like how much of the space you're going to need for it.
Yeah. And we'll usually draw this out along with some preliminary elevations, which we can also identify on like a preliminary design package. This is before we get into the construction documents and schematic design.
Well, and that's like program, and then when you're programming, that's when you're trying to arrange all these different uses onto some kind of cohesive adjacencies, and I need the loading area close to this area because of this reason, right? So that's the exercise to actually lay it out.
Another key element of the programming, when you define, for example, programming, then you assign the square footage area to it, and you're actually creating almost like Excel spreadsheets with like a room names, and then you actually based on codes and all other regulation, you're defining the sizes of these spaces. And depending on how many people they're going to have office space, how many people they're planning to have in office space.
Some clients we worked with in the past, they had certain things that were predefined. Mm-hmm. So we'd come into an existing space and they would say front of house needs to be 70%, back of house 30%. And those are like, back of house was like always the critical number. It's like, that's the max. Because again, you want the most efficient use of your floor plan.
You want customers in your space making
buying
you money.
Stuff, right? Yes. Versus like the back of house, which is just storage, but you also need it.
Or it might be a kitchen and you would have to design it as efficient as possible so that we can maximize front of house.
And can be from one single page to God knows huge documents. I work on a project when I have a programming we've been doing like for almost a month with application of all codes, FGI guidelines, and
Scott
etc.
on Be Aligned, on the Be Aligned project, he really got into it, and he would make these spaces with the square footage and cut the piece of paper out and then arrange it
Architect do that too. Architect do that, the same exactly thing.
And when you're talking about like residential floor plate too, you know, all of your like circulation and other areas, there's a certain percentage that you want to be for your units versus all the circulation if you have like a multifamily building.
So it's almost like now what he was doing is actually almost like a transferring the programming to something that is called like a bubble diagrams.
Yeah. All right, I'm going to move on.
Yeah, well, that was a big one. Yeah. I'm sure others will be a little smaller, but
Let's get in some drawing terminology. So when we say section, or we want to draw a section or look at the section, what are we referring to?
I'll let Paul answer that.
Oh, this is Nino's, I think, all your young architects in your office, give me a section, and then they just start chopping away.
Exactly.
Yeah.
So
it's basically a cut. You know, and a floor plan... Technically, a floor plan is a section too.
Yes.
Because a floor
horizontal
plan,
sections.
A floor plan you are cutting. You have a certain elevation that you're cutting at, and that's your floor plan. So a section is just basically the same thing, only oriented to where you're looking at a vertical cut through the building. And the critical thing about when you're doing a section, you really need to think about it should be purposeful. It should tell you something that in the 2D floor plan view, the horizontal cut cannot tell you.
Exactly. You know, it's usually heights.
Yeah. So if it's a head height clearance, like if we're doing an attic conversion and it needs to be a 6'8" clearance or 6'8" clearance, then we need to show that somehow. That's where the section comes in.
Yep. Yeah. For example, usually sections that you do like sections through the stairs, like stuff that are really important, and you don't want to cut the sections from something. You just get one information. When you're cutting the section, you're cutting from the piece of the building. And I usually ask my like a younger stuff to cut through the stairs, where vertical communication's happening, and you need more information on that.
Yep. And then within that, we can have our details.
Exactly. Yeah. Or where you have multiple changes of the levels. Like I have like a, but you have
Yep.
this house is like a split level. So then I would like to cut through all these different levels so people can understand.
Yeah, it
Yeah.
can also show like this space being isolated
Yeah,
and how it's
exactly.
connecting to another space on a
Or
different
double
plane.
story space, atriums
Oh, yeah.
and stuff
Yeah.
like a balconies and all this stuff that
Yeah, understand what's open to below or above.
above,
Yeah.
exactly.
Yeah.
Okay. Next is elevation. I think we mentioned that just now
I was
also.
going to say, can we toss one of these terms to you? Like elevation.
sure.
Yeah,
What,
you
what does
do.
elevation mean to Nick?
When I talk about elevations,
Is that when you go into the mountains, like when you're skiing?
no, I don't ski, Paul.
Oh,
You
okay.
ski.
Okay.
Um,
Sorry, I'm
I-
still in ski mode.
I go to the
elevation.
ocean.
I was thinking of.
I
yeah.
go to the ocean.
Well,
Nick
that's-
is,
that's
Nick is like
elevation
me.
That's sea level, right? That's
Yeah.
elevation there.
Fair,
Yeah.
fair. When I talk about elevation to our clients, we want to talk about the facade, which can also be another
Yes.
term we can discuss, and it's basically the exterior of the building. How is this gonna look? How is this changing? So if we're adding an addition, or if we're doing some type of cladding or curtain wall or some type of exterior finish, we want to be able to communicate that in a drawing.
And it's still like a two-dimensional,
Yes.
elevations are usually two-dimensional when you put informations about materials,
Yeah.
about like a relationship between windows, like I put some like a roof component, slope of the roof, what materials we're using for a roof, and that is just like, and we usually like depending of the building geometry.
Yep.
But we usually have like for a basic building, we have like a 4 elevations,
So
or
for-
they can go even more.
Preliminary design elevations, like preliminary elevations, are important
Mhm.
because, like, well, what is this going to look like? What's the basic concept?
Yep.
So in schematic design, this kind of exercise of sketching and like basic.
Still playing with the geometry of
Exactly.
the space. Yeah.
Yeah.
And whenever you go to zoning or architectural review boards, they want to see what the building's going to look like.
Exactly. And
Usually zoning, you have a site plan and you have elevations. Those are the two primary
Yes.
things.
They don't care too much about what's going on inside. They want
Yeah.
to know what it's.
yeah,
how it's
exactly.
looking. Yeah.
How it's gonna look like to your neighbors, to the community.
Yep.
Yeah.
Cool.
All right. We did touch on plan, but we can get a little bit more into that because it's the main tool we use to do a design review with our
Yes.
clients.
I think it's the basically next step of refinement after you do your programming, right? So
Mhm.
once you have your square footages and kind of the general layout, then you actually start to go in and again, it's like you're looking at door swings and wall thicknesses and everything gets laid out in a floor plan. And
Yeah.
like you said, it's the main way to really communicate how the space is flowing and how everything is actually communicated in a very detailed sense.
Yeah,
Exactly.
and you mentioned it's a cut. It's not cut vertically. It's cut horizontally.
Horizontal, and we usually cut somewhere around like
4 feet.
4 feet. Yeah.
Yeah.
Sometimes if you have like a higher windows, then we just like a portion of that plan we cut it higher, so you see there is a window, but on a higher elevation there. But sometimes you just use like a help of elevations or sections to find that windows in
Yeah.
the
And
plans.
I think it's probably good to note that when we cut through a wall, it's gonna be defined as a solid surface. So it's gonna be like a dark black or a dark
Mhm.
gray. If it's a pony wall or half wall, it might just be the outline of the wall, and that will represent a half
Because
wall.
it's a lower, we don't cut through it.
Yeah.
Yep.
So
Yeah.
it's not an actual cut.
But then we
you still
have
see the
to-
top of the wall.
We also have like something that is called enlarge plan. If we don't have a room to put all information for certain areas, like for example, you have in kitchens, you have a lot of cabinetry and stuff, and if you want to
Your
try
dotted
to
lines.
exactly,
Yep.
you want to dimension something, then you actually would like to make the enlarge plan so
Yeah.
it's on bigger scale, and we're gonna talk about scale too, so it can just be a little bit easier to read. the
Or
plan.
like a restroom, like ADA restrooms is what I
Yes.
can really like
Exactly,
think
with
of.
all
you,
the clearances. and
you have
stuff.
your
Yeah.
clearances for the toilet, for the sink, you have your turning radius, clearances for your door. Yeah, all that stuff should be shown, dimensioned.
And back on elevations, we also have interior elevations, like elevations of the millwork,
Yeah,
like in a
absolutely.
kitchen. Yeah.
And it kind of, now we've been looking at this for 20
Mhm.
years, but when you look at all these different dimensions and
Mhm.
line work and line weights, we're able to see like it's a 2D drawing, but we see 3D.
We still see it in 3. That is, I'm glad you're mentioning something which is the line thickness.
Yeah.
And many younger kids don't even bother with that.
Right.
But thank God, like a software now help us with that. So usually if you're cutting something is a thicker line, but you see down below, like we're talking about that like island, that's a thinner line.
Exactly.
I think the other thing to keep in
glad
mind,
you mentioned that.
keep in mind too, is all of these things have to be together to tell the cohesive story.
Exactly.
You can't just have a floor plan and have the whole story told.
No.
No. Yeah. So I think all of those tools used for drawing are critical to tell the whole story.
Of course.
Yes.
Otherwise, why would we do the other drawings?
Exactly. why would we bother?
For fun. Yeah.
Spend time on it.
Oh, this is a fun one. I don't say this word too often, but we talk a lot about it because it's very important when we're designing the exterior of a building. But fenestration.
Yes. Fenestrations are all openings, everything that brings the light into the building.
Yeah, and
daylight.
The arrangement, the relationships that they have, the privacy issues.
Yes.
Even when we were dealing with historical commissions, like the actual detail of the windows and doors and how they're related. How are they opening? What all the details of that.
That's all subject. If you have them on a walls or you have them on a roof.
Yeah.
So yeah.
Next one, schematic design.
We kind of touched on this a little bit in programming, but schematic to me, it's just anything early on where you're trying to figure out what this is going to be.
Yeah, we see it's mostly in commercial work.
Yes, and I will say that's actually the next step after the programming. So, and you do the programming, you do these bubble diagrams when you're a little bit playing with this like surface and areas. And now you start drawing the connections between the areas, proximities. And also now you start putting the layer of the first code reviews. So you have like a paying attention of the egress requirements and stuff.
You're probably getting into your first like actual plan drawing if you're going into schematic design.
And then you will see in schematic design, you will start seeing first schematic design elevations, maybe first like a 3D rendering. So that's all part of the schematic design.
Yeah. You can also, I know you say preliminary a lot. It's like those two words are almost interchangeable.
Yes.
Schematic, preliminary.
Yes. Yeah. Yes, they are. Yep.
Although it always ends up as pulmonary when I'm dictating.
Exactly.
That's a important distinction.
And you just need to enunciate.
And how I actually usually after that comes design development, and how I usually tell all my clients what is the end of this schematic design, the design development. I usually tell them, okay, guys, after design development, no more user meetings. We are locking our floor plans. Now you're gonna give us a time to develop this plan.
Well, yeah, because further. You have to go through MEPs and all this other things.
You have to do coordination and stuff. No more changes. Let's lock the plan.
I will say one more thing on that note. As far as we really don't have too much schematic design in the residential side unless it's like a luxury or custom home. Because of the cost.
Yes.
Right?
Yes.
And the time. And usually we're on a faster timeline for these smaller projects.
And I can tell you from my experience, since I'm like a senior project manager, I see more and more often that we as an architect, due to the fee competitiveness, that schematic design starts to suffer, just getting shorter and shorter.
Right.
And that actually as an architect bite us later. You have to go through this exercise.
Well, I don't want our work to suffer. So the way we navigate that on the residential side is we're like, I'm sure you have a vision in mind of what you want your house to look like. Show me a beautiful home and an elevation, and some elements of architecture that you're looking to go towards.
Oh yeah, for a single family home is much easier procedure, but for
and then we'll have our input, of course, and we'll go through their same design review process. So we'll get to where we're going. But if they have
it's much faster.
Yeah, if they have something to start us out on, it's a lot easier.
Oh yes, if they have vision already in their heads. Yeah.
All right, egress.
Oh, this is a fun one.
It is the fun.
Actually, it's an important one, and the city is cracking down on it too.
It's like a number one thing when you go to do your.
It's your escape path.
Yeah.
It's actually if something goes south, house is on a fire.
Life safety.
Exactly. Yeah. So that's your distance from the most remote point in your floor plan in your building to the first door. That actually gonna get you out. And I say so that's that distance from the furthest point to the exit.
Yeah.
Exit door.
As an architect, that's the number one thing that we're, the HSW, the health, safety, welfare of the public.
Yes.
And egress is your ability to navigate out of a building. You know,
Yes.
for whatever reason you need to get out, it's clear, simple, and you know the path is defined. And if it's too long, like Nino said, if there's a certain distance, you're adding a door or you're adding a rescue opening or something. You know?
And it's usually corridor. You shouldn't egress through like a storage room. I don't like people egressing through another room to get to the out. So it's usually like a corridor that.
Or fire separation is like egress components. Like there's fire separations that come into play. Yeah, and you're right. Like you can't egress out from a lower hazard into a higher hazard and then out.
Yes.
So like if you're going from like a back of house area through a kitchen, because the kitchen's a higher hazard area,
you're jumping over the islands and cabinets.
Yeah,
and
that's probably where the fire is anyway.
Exactly.
Oh, in the kitchen. Yeah,
exactly. Yeah. So yeah.
I would also say too, we deal a lot with egress windows and speccing those out. And some of these windows companies now, to save costs, which is a good thing in some cases, are now their windows are not opening like even 50% if it's a double hung. So now we're looking at casement style or sliders or something. But I mean, there are a number of things to consider too that the city looks for to make sure for safety.
Yeah, and most important thing when you're egressing, when you egressing to out, it needs to be public way. So you cannot egress to like a enclosed yard. Enclosed yard is not public way. That means you're exiting from the building to the public way, to the open space, street, park, whatever, backyard.
All right. I think we mentioned this, but MEPs.
I don't think. Well, yeah, kind of a little bit. Yeah.
Mechanical, electrical, plumbing.
Yeah, and I'll put T and the bigger commercial project, which is technology.
Yep.
Yeah, you can throw structure in there too. Basically, I'd say like any engineering partner, essentially.
Engineering partner.
Civil engineering can be grouped in here as well. So.
But usually you heard the MEP.
Yeah.
Which is common term for mechanical, electrical, plumbing. Yep.
Yeah. But yeah, obviously as an architect, we're only dealing with the design, the spatial planning. We're not getting into how many BTUs are needed to heat and cool the space. We're not getting into electrical loads in your panels, right? Like we have to partner with engineers to provide all that.
Yes.
How many vents you need for the plumbing system.
They have their own plans too.
Yeah.
Yeah, on the residential side, we'll put equipment placement, clearances. We'll show vents, but we don't calculate like CFM or anything like that.
We provide some basic
information. We do load calcs actually now. Yeah. The city's actually starting to ask for that.
And we do provide CFM airflow requirements.
I saw. I actually saw your drawings. Yeah.
We list code requirements.
Yeah, exactly.
We don't calculate duct workflow.
Yeah, we're still not doing like a BTU like energy analysis or anything like that, but we do have like, hey, this space should have 150 CFM provided.
Awesome. Ooh, this is a fun one. Nino, you're going to love this.
CFM, cubic feet per minute, right? So that's like the amount of air that goes to the space.
Flowing through.
Yeah.
All right, here's a fun one. Value engineering.
Value engineering.
This is not fun.
It's not fun. It's usually very painful for both the architect and the owner.
And the contractor, everybody. It's painful for everybody.
Yeah, and it's all usually like in the hands of the contractor, and coming back to you and just saying like, hey guys, this is too expensive.
Yeah.
Now we need to start cutting the cost. What is the less important things on this project? And you're gonna say everything is important, and it was like no. So let's start cutting the cost. You pretty much removing the less priority items from your project in order to meet
the custom elements that like windows.
Exactly.
Instead of like the white oak, reception desk, you're getting like a plastic Corian, laminate or something.
Or if we don't want to sacrifice quality, maybe we cut down on the square footage a little bit.
Exactly. There is that, but usually I see a reduction in first. I will say the first reduction. I will say interior finishes, exterior finishes, and then if really that doesn't help, then reduction in square footage.
It's hard to do square footage though, because usually when you value engineer, you're to the point in the process that
you've already determined the square footage
by programming and schematic design and all these things. So to cut the square footage is really drastic measure.
Yes. Unless you are, once again, I keep dropping in commercial world, but unless you're like in a design build and you have something called GMP, guaranteed maximum price, then you actually can do major cuts during the schematic design scope and the cost review. You can actually do. I remember we sometimes lose like a 1/3 of the building because of that.
Are you when you're that far off, something there was a disconnect. So are you then reaching out to like estimators to price out this project?
No, it's usually in that situations like in design build team, like the contractor is the one who's doing the cost estimate.
Okay.
So he's the one who's guaranteeing the maximum price. And what in big projects or middle scale like a commercial project, very expensive components are like all these mechanical units and equipment. So then you scale down, but no, it was literally like it was the SD. We were in the SD phase, and we lost like I won't say 1/3, but at least 1/4 of the building was out.
Wow.
Yeah. It was like but that happened during this period of the crazy increase of the COVID times. When it was really hard, very hard to estimate. Yeah.
You wait 24 months for an electrical panel?
Yes.
Yeah.
Yes.
Okay.
Or 3 years for a generator.
Yeah.
I'm glad those days are over.
Yep.
Yeah.
Supply chain issues.
Envelope.
Oh, I got one in my closet here.
Yeah.
Do you need to mail a letter?
I do.
Yeah. I do have. Still have a couple.
Oh, you're talking about a different envelope.
Yes.
Okay.
The building envelope.
Okay.
I'll usually call that building skin. That's pretty much what it is. It's actually your skin around your building, your
the
perimeter, exactly. Your walls, your windows, your roof. That's all envelope.
All right.
Yeah, anything. Just think of it as anything that touches the exterior.
Exactly.
Is part of your envelope.
Or enclose your internal space.
Yeah.
And usually that'll involve energy efficiency and things of that nature.
Oh, yes.
Yeah. Depending on what the wall construction is, sometimes you have like a double skin, even,
Yes.
to allow for like thermal transfer of a certain way and airflows. And
there's double skin.
Yeah.
Yep.
Now we're having some fun, you guys.
Oh, yeah.
All right, let's take it down. Let's go a little more simple here. Column and beam.
Vertical, horizontal.
I was going to say, I hope our clients know that one.
Structural members that go vertical and horizontal. The interesting thing, though, that reason I wrote that down was because, as architects, we will design, at least on the residential side for me, a structure with dimensional lumber within the RCO, right, within the Ohio Residential Code. Or whatever state we're in. And if we do need an LVL, which we should probably call that out too, which is a laminate.
Laminated beam, yeah.
That is kind of outside of that box where we'll have to now engage a structural engineer to do those calculations. Or get a cut sheet from the manufacturer that's going to be a pre-engineered member.
Yes.
Yeah. That is the most simple type of structure, by the way, column and beam.
Yes.
Yeah.
Architecture history.
Post and lintel or
mortar or no.
What? They talk the volcanic?
What's the convex and concave connection of blocks on ancient architecture? The master builders did it for like castle walls.
Oh, you get me there. I have no idea. Now we have to go back to the history books and read it.
You talking about where you have like an archway that intersects another archway?
No, but that's another good example of the same of another strategy within that type of building.
I think it's a groin vault maybe.
Yeah.
Because you have a vaulted archway intersecting another vaulted archway. I think it's a groin vault.
You just wanted to say groin.
I did, yes. I did. I think it is.
Now it's getting interesting. I love this. From very simple.
Shout out to Robeson for architectural history terminology.
Yeah, he was a good teacher.
He was a good teacher. Yeah.
I was actually when I was in Europe, I was trying to think of all these terminologies, like the dentals and the coining and all the other stuff. Yeah.
Yep.
Okay, let's move on. Load-bearing wall. That's an easy one, right?
That's an easy one. That's
really just anything load-bearing. Like, what does that mean?
Yeah. So that's actually the wall that actually carries all that carries the floor above, that carries the roof above. So that's the structural component of the building that transfer the structural load all the way down to the foundation.
Yeah. So if we would remove that wall, we would then have to
add posts and beams.
Yeah,
there we go.
You would have to basically anything that has weight is what that is supporting.
Yeah,
right?
exactly.
You have to take care of all the gravity and force. Even wind, there's wind forces that come in. So if something's
lateral
load bearing
forces,
and lateral forces are being taken up with a shear wall or something, all of that has to be accounted for structurally.
Yeah, that's true. But I will make the distinction between shear walls and load bearing. Load bearing is really transferring the loads of all building components down to foundation.
Yeah. Yep. By the way, it is groin vault.
Oh, nice.
Good job, Paul.
Yeah.
I also just wanted to say groin, I guess.
It kind of looks like a groins.
Yeah.
Maybe that's the reason why they call it.
Let's move on to...
I love this podcast. Yeah.
R value.
Ooh.
R value.
Yeah. Is this a new crypto or something? What's R value?
Yeah. We're going to start with the crypto.
Careful the cryptos.
Nick is sensitive to that.
Actually, maybe we should make a cryptocurrency called R value.
Yeah, why not? Yeah.
I don't think people are going to buy it.
Yeah.
Yeah.
All right, so what is R value?
Basically, it's a number that's assigned to anything that's providing thermal insulation.
Yes.
Yeah.
So, usually in your ceilings or in the rooftop, you have a higher R value, like a R49, versus in your walls, that might be like R20. And that's because, again, physics, heat is rising. And so to keep all the heat into the building, you're going to want
provide the resistance of the transfer of the heat.
You want your
or cold
envelope that's on the upper portion, your rooftop, to be insulated thicker.
The most, because that's where most of the heat is going to be leaving.
Yep.
Or trying to leave.
Try to leave.
Because
and
heat
it's usually assigned like to the walls, to the insulations. When we're talking about windows, then we use something a little bit different that is called U value, which is actually R value divided by 1.
Some inverse ratio or whatever.
Exactly.
Yep, and all these values change depending on what we're dealing with, whether it's the commercial building, residential, new construction, a rehab. There's all different standards and requirements.
Exactly.
Commercial, you might have something like a comm check that comes into play. You know, or if it's an existing building in residential, you might actually get away with R38 instead of R49 for your rooftop.
Yes.
So.
Yep, and you might not have a choice because you don't have space because it's just a 2x6.
Yeah.
Truss. No, not a truss, a rafter.
Yeah.
But usually these values are dictated by the code because of the thermal performance of the envelope. So those sustainable. So you use less energy for heating and cooling by providing the thermal resistance of your envelope.
Where you live too is also going to dictate what that value
what
is.
Zone? Yeah.
Yeah. Because if you're in Florida, your R value is not that high.
Sure, it doesn't need to be.
Yeah.
Oh, cooling.
Although I will say this.
Cooling, yes.
Yeah, so maybe
so
it
still
does.
You still
something, but again, it's not rising up and out. So
That's
like your
true.
rooftop is going to be a different
Do you
R
know
value.
Do you know what is going to be difference? Where your vapor barrier is going to be.
100%.
So it's going to be in front of insulation in Florida. It's going to be behind insulation here in Columbus.
Yeah. I like to think of architects, we're always battling Mother Nature, like whether it be moisture or vapor or rain, water, air. Like we're trying to manage all these things to keep the space conditioned.
Sure, if you're getting all 4 seasons and the summers and the winters are extreme, then
that's good. That's actually a really good segue. But talking back to the envelope, protecting your building from all the elements. Yeah.
All right. I think I mentioned it because I was just looking at the next item, but truss.
That's a trust too, in system trust in trust bank.
SS, no ST.
I know.
That's a fail, Nino.
I failed the course. Yeah.
Another structural item. So usually it's pre-engineered.
Yep.
Yes.
So trusses are actually kind of nice because then it's like a little bit of a pass on the architecture side because it's just like, well, it's the engineer is going to calculate it and draw it up.
We'll still show this. We'll still draw it. We'll still show the spacing, and then it will be up to the lumber package or the engineer.
Benefit of the truss in comparison to the beam, that truss is the lighter, but it's structurally in that way that actually allows you to spend much higher distances, and also allows you to even run some ducts through these trusses because they're
all open.
They're all open. It's made from the actually posts that are attached together, usually diagonally, and transfer the forces inside.
And that's what gives them their strength. So it's
exactly
this diagonal or triangle
that
geometry.
Yeah. triangle is one of the most stable structural component. Geometry, if I can say it.
It's an assembly that's made up of all these individual pieces.
And if you think of it, the top two portions of the triangle is your roof, and the bottom portion of the triangle is your ceiling. In your space, and then you can insulate on top of that.
Exactly.
And there's I don't know how many different truss profiles there are, but there are
you usually have like you have top, bottom chord, and then you have this like
the webbing
of the posts in triangle shape usually.
I still remember remember that new house that's monstrous 5,000 or 6,000 square foot we went into in like Powell or something. And we went into the attic space because they want to expand it, and there was just so much webbing. It was like the house was only a couple years old, but just the webbing in there, it would just been fun to be a kid and like play.
Oh, I know, like going in between these webbing.
Nick's adventure course.
Exactly. But usually, that's a good point. You usually use trusses for if you want to achieve big spans without too many columns in your in your space.
I think and trusses have gotten affordable, and in terms of labor, it just saves a lot of time too. So, all right, now those last few are going to be fun for me. And, I'm really excited for you to give your 2 cents on this. Green roof.
So green roof. It's a roof painted in green. So if you just let kids...
You actually, I learned something today from you. Because you said not only green roof, but there's another terminology.
Yeah, there is a purple roof.
Yes. That's like when the roof gets bruised, you like beat it up.
No. It's pretty much what it is.
All right, guys, let's stay on track here.
Sorry. The first time I heard that terminology about, let's say, green roof is your vegetated roof. So, and it's usually like it can be like it can be also used like for people like walking on that roof. So it can be occupied space.
What are the besides nature? What are the benefits of having a green roof?
The benefits of the green roof are actually multiple. First, you're reducing the heat island because
I know Chicago, for any new buildings that were in Chicago, there was a green roof requirement. To reduce some of the heat island effect of the city.
Especially if you can't put any green space in on the site itself.
So it's a concrete jungle.
As we know, the cities are concrete jungles. They produce more heat because there is all these reflective materials in it, materials that absorbs the heat and creates more. And also, the green roof is a really good, like I will say, the envelope performance component. Because instead of like, if you have just a concrete slab hit by the sunny day, that slab will absorb the energy.
Giant battery.
Then will reflect that energy when you go to sleep, and then you have to turn up air conditioning all night. Green roof will actually like dissipate that energy and will not transfer that energy into your space.
There's so much. There's also tax credits you can get on creating if we have like animals like bird sanctuaries and insects. So if we put the right plants,
pollination,
so you can create these sanctuaries, I'm doing air quotes, and you'll get tax credits to foster these environments.
And
bees.
And the runoff for a stormwater.
That's where the purple roof comes into play.
The purple roof comes in it because, as you guys know, city streets can get flooded during the like decent rain that like rains like for an hour and two.
Well, you're gonna have flood. Your system.
Overwhelming the system.
Do you remember Houston when they had the hurricane and the entire city of Houston was flooded? It's because they had all this major development. And they didn't take into account all the stormwater surge. So when they had that storm, literally the whole area was flooded.
Not surprised for Texas. I don't think that they even have any zoning regulations. So
because it probably only happens like once every 100 years.
But I mean, like you saw the impact of it. If you're not thinking about it and it's implemented across the whole city, all of a sudden it's like the whole city is flooded.
And another thing is like I remember we were working on one project. It was actually one of the research and lab. It was entire building is dedicated to the insects and agriculture in Worcester, and they have this like it wasn't actually a roof, but it was a little garden, and that is called pollination garden. But the old kids will actually look the bees doing their jobs. I think that's
awesome.
That is awesome.
And honestly, it's like there's some extra material that you're putting up on top of the rooftop. So there's some extra loading structurally that you you have to support.
Oh yeah, you have a soil.
But it's like the benefits that you get at, well, and if it's a purple roof, the stormwater.
Yes.
But the benefits you get out of that system being there, again, like having structural components a little bit larger to support it is minimal compared to the benefit
for this project we went from the green roof to the purple roof is to still achieve our LEED credit, and to save the cost.
Can you tell the audience what LEED is?
LEED accreditation is the accreditations for that actually measure the let's like just say like the measure the how sustainable your building is, how sustainable performance of your building is, and through all kinds of different credits and measurements.
Yep, it's something that's really important to most architects, but it's the importance has kind of dissipated over the last probably couple decades only because of the cost to do some of these things.
Yes, but it's still like many big clients use as a really good marketing tool.
Of course,
telling everybody, you know what, guys, we're building this new facility, but this facility will actually benefit in multiple ways, not just provide the accommodations for new services, but also is not going to harm the environment around it.
I would say because it has a lot of passive and active elements, and I would say like for typical architecture, it's cost prohibitive.
Yes,
right?
it is.
But if we're doing a public library or some type of
even if it's a major building, like I know there was one in Times Square, like I remember again 20 years ago.
It filtered the air.
Exactly.
Yeah, so literally it would clean the air.
Yeah.
Right. So the air that came in was clean. But when it exhausted out, it was cleaner than when it came in.
Or you know what? It's gonna save it's gonna save like the owner the money, because over a certain period of the time is gonna reduce the operational cost.
Yeah.
So cost of your energy during the time is going to be much more affordable.
Yeah, and energy costs are just going to go up.
Exactly.
A lot of public structures that are going to be serving the public should have more of those types of standards, in my opinion.
Yeah, I think the other thing to consider too, just with the climate and the way nature is, again, it's like a backup system. If you have some of these systems integrated into your building, be it solar, battery generated, you're generating your own power.
Exactly.
And you're not relying on the grid to deliver energy to your
building. You
building.
even can push back in the grid and get the credits.
And as you know, at least the last couple decades, we've seen power outages.
Yeah.
Oh, yeah.
The one power outage hit us, like here in Columbus, and I had to go over to Nino's house because it was like 100-degree heat.
Yeah.
100-degree heat, and our buildings are not created to
I was sleeping in my basement trying to stay cool, at least some of the thermal, but I mean, like even that, it was brutal.
It's like, especially like for a big like a public buildings, resilience is another key element. I mean, if you can just see like happen during the Katrina, like that if you guys ever watched that movie about one of their hospitals, it was a pure crisis, I will say. So I forgot the name of the hospital, but yeah, the hospital was the old, and just happened they have all this generating equipment in the basement, and that was the first thing that flooded and shut down the power in the entire hospital.
Yeah,
it was a nightmare. Yeah,
and that type of infrastructure is, we need to keep the hospitals up and running.
Exactly.
So that's kind of a drop of the ball of the designer, because why would you put the equipment down on that level?
Because of the low cost.
Right.
Yeah, unfortunately.
Well, I didn't want that to be
I know.
So we're gonna talk about passive design before we stop this. I don't want to end on that note.
No, definitely.
So, passive design, which is honestly not expensive if you do it right. So this is a great thing.
This is like the Earthship almost conversation too.
Yes.
Yeah, we're gonna do a separate episode on that.
Yes. So this is, I will say, like the first passive component of the design is proper orientation of your building.
Yep.
So it was like I usually would like to say like, do you want to put the kitchen on the west side or a south side, or you want to put like a living room on the south side? Why is that important? Because through the year and through the function of your building, through the like, for example, one calendar year, you will see like the exposure to the sun, exposure to the cold, exposure to the prevailing wind. If you really cleverly design your building, you can actually use these forces of nature in your benefits.
Yep.
So
heating,
cooling, like a south exposure. You can actually utilize the south exposure to heat your living room during the winter months.
It's like one of Frank Lloyd Wright's like principles with his prairie style with these overhangs that extended and projected out. During the summer, it was shielding you from the sun.
Exactly.
And during the winter, it was enough to allow the sun in to actually warm the space with
and
solar radiation.
Yes, solar. And you can actually even play with your landscaping. Like you can put your the trees. They're gonna lose the leaves during the winter and
huge components.
Even you can use your overhangs. You can also use some of your patio walls or trees to shield you from the predominant winter winds, and then allow you to actually utilize the summer breezes. It usually comes in different direction.
Or if you have topography, like down in the not the cliffs, but your property in Hawking.
Yep.
Do you have a name for it?
Rich Hollow Retreat.
Yes.
So down at Rich Hollow, if you actually dig into a hillside, right, and shelter some of your building within the hillside.
And use the thermal properties of the earth.
Yep. Exactly. So you get like a free battery of energy
Exactly.
there.
I mean, even the material inside themselves, like if you have sun coming in and it's hitting, say, brick or some type of masonry, that will now hold that heat.
Do you know what is the name of the first one of these first houses that was utilizing that was actually semi-digging into the hill? There was a Socrates house.
Really?
Yeah, yes.
Wow.
Socrates' house is actually, and it's like a funnel shape. Yeah. So it actually opens up towards the light and then closing out into digging into the earth. And even back in the days, they knew it, how to actually, why should I insulate 3 sides of my walls if I can dug it into the earth, use the earth for that, and just open one big side maybe to the south exposure and accumulate all light from there.
It's a very powerful force. I mean, think about when we have days that are pretty warm, pretty cold. Yeah. If you go into a parking structure in an urban center and it's nighttime, you can feel the heat coming off of it.
Oh yeah.
Right from the concrete.
Radiating.
Yeah.
It's radiating.
So I'm sure back then it was a mountain or hillside that was rocky, but they could probably feel that heat coming off of it.
Well, that goes back to all the new standards for parking lots, landscaping and within parking lots, and green roofs, which we just talked about to help mitigate that.
All these components are so tied up together.
It's when you're looking at it, you're not just looking at one individual thing.
No.
You really want to look at 5, 6 different
That's a
components.
Holistic approach. That's what is beautiful about architecture.
Because that'll give you the most impact, and really make an impact on what you're paying for utilities and what you have to actually pay to heat and cool the space.
And sometimes you have to do the balance because you have a cost and you're going to say maybe it's better for me to utilize sun and spend less money on the wind because I don't have strong winds, or maybe why should I spend too much time trying to utilize sun if I'm, for example, in Seattle or Cleveland? Maybe I should utilize the wind. So it all depends of your local, like
in Hawaii, they actually mandate on any new build residential that you have a solar hot water heater.
Yep.
Yeah.
Because again, the environment dictates that it's a perfect environment for you to get the sun's energy.
You're an island. You have to bring all this power somehow.
Yeah.
You have to generate the power. So power is limited.
Yeah.
It's not unlimited. Yeah.
Yeah, I think it's important to mention that I just want to reiterate, passive design is not expensive.
No.
I mean, typically we're going to have this conversation only when we're doing a new build in commercial or residential, but it is something that you can do affordably that will benefit you.
Yeah, and it's usually something, when you say passive, it's like a sun shading, is utilizing harvesting daylight. Screening. And the active is more like a photovoltaic systems when you're using technology to help you in your sustainable
which is
growth.
Now starting to become more affordable, at least some aspects of it.
And you also can actually combine these two into very effective system. Yep.
I love it.
Is that a better ending point for you?
I like
more optimistic.
Yeah, I feel
more
good.
Optimistic. I like the optimistic endings too.
Well, we're gonna stop there. We'll probably have another educational series and dive deeper into some of these topics.
I think, like you said, Earthships. We'll have a guest on and talk about they use a lot of these passive and active systems.
Yeah, I love it.
Yeah,
cool.
Well, thanks for joining us, and we'll see you guys in 2 weeks.
This has been the ArcFluence Podcast. As always, you can get more information and additional content on arcfluence.com. Please subscribe on the platform of your choice and leave us a review. We'd love to hear from you.